Okay, so we're going to start off again right where we left off. And you can see that we said when you want to name refrigerants, this was developed by DuPont Company. Let's say you got dichloro, trifluoroethane, 123. Notice this is how they come up with the number 123. The number of fluorine atoms, the number of hydrogen atoms plus 1, and the number of carbon atoms minus 1. So it ends up being 123. That's how they come out with these numbers, okay? Now, refrigerant blends. I did a whole lecture on this. If you look at lecture 4 from last week, I explained this and wrote it out on a board for you. You're going to keep hearing the same things for these 3 weeks because they're all leading up to the EPA exam. Now, the definition on 232 is a blend is 2 or more refrigerants put together to create a refrigerant. Okay, that's what that is. Your HFCs are long-term replacements, 134 and 410A. Okay, if you need to go back to that last lecture video, I tell you exactly what an azeotrope, neazeotrope are. Okay, I explain what fractionation is, and I explain what temperature glide is. Go back to, I believe it's either lecture 3 or 4 of the last chapter. It's still on the class YouTube page, and you can watch me explain that. If you can't find it, you're having difficulty, text me. On 235, look what it says. Okay, you have a toxicity rating for refrigerants, okay? So it's right here. I'm gonna bring this over here for you so you can see it. Notice it says lower toxicity starts with A3, the greatest amount of toxicity, higher toxicity, higher flammability. And so these are the ratings for the refrigerant, okay? Whatever refrigerant rating that refrigerant has, like let's say it's 134A here and it tells you what the rating is, A1, you go look here and it says no flame propagation and low toxicity. That's how you look that up. Now I'm going to name some of these that you need to read through here, okay? Your next few pages are a whole bunch of different refrigerants, but I'm just going to name the most common ones you should be familiar with. So in 235, you should be familiar with what it says about 134A. It follows the PT chart of R12. It's used for automotive and domestic refrigeration and air conditioning and things like that. The next one you should look at is R22. This is not a blend, it's a single compound refrigerant. So it's called. It's classified as hydrochlorofluorocarbon, but it's not a blend. It'll be phased out in 2020. The next one is 407C, near azeotropic long-term replacement for R22 that people use in systems now. 237, page 237 tells you about 410A. Now this is a neazeotropic refrigerant blend for R22. 410A has a higher efficiency and it is a long-term replacement. The problem with it is the pressures of the system. Okay, look right here. 410A. Evaporator pressure 130, condenser head pressure 365. Okay, but look at your refrigerant here of R22. You got a 76 evaporator pressure and a 226 head pressure. Notice the difference in pressure. Big difference in operating pressure. However, 410A evaporates in your evaporator at 40 to 43 degrees. Normal operation of a residential system, just like R22. So it doesn't matter what the system pressures are in relationship to that, as long as you're getting those temperatures. It also has the same condensing temperatures as R22, but 410A's got a lot higher operational pressure. But notice you're going to get the same condensing and evaporating temperatures. That was the big thing that they had to arrive at. The next page, 238, you should read through 404A a little bit. It is used in commercial, low temp. Then on the next page, you should read a little bit about R12. It's ranged in small hermetic systems and things like that, and that's been phased out a long time ago. All right, any questions about that? Okay, next one will be on page 241, and we'll talk about oil groups. Okay, different oil groups.